Anyway, my name is Federico Mena, and I've been doing a lot of work on porting things to Rust, as many of you already know. During the last 2 or 3 years, the librsvg team ported the whole library to Rust. Now the turn is for gnome-shell's styling machinery, which shares many of the things that librsvg has for CSS processing. The reason for doing this is twofold. gnome-shell uses a library called libcroco that is a very old and unmaintained library for processing CSS. And it's written in C. It has had a couple of vulnerabilities in the past. So it would be nice to replace that with safe and maintained Rust code. By the way, that's my email address and my Mastodon account. I don't really post on Twitter, so if people want to get in touch with me via social media, get on Mastodon, and I'm right there. Let's get on. gnome-shell uses its own toolkit for drawing windows and buttons, the top bar, all of those. And the toolkit is called ST. ST stands for Shell Toolkit. And the code, the initial code for ST is actually pretty old. It comes from HippoCanvas. HippoCanvas was a thing that some GNOME developers wrote more or less during 2006. Back then, there was this, I believe it was a Red Hat project called Mugshot. The idea was to kind of gather all the social media accounts that people had back then, like your RSS feed for your blog and maybe your microblog from Identica, maybe your Flickr photos or something, and to gather them all in the same place. But then Facebook and Twitter got popular, and the Mugshot project just disappeared. But they left us with HippoCanvas, which was actually a very nice derivative of the really old GNOME Canvas. GNOME Canvas was a retained mode graphics infrastructure that many applications used back then. So we now have HippoCanvas in the form of ST. And it's basically a retained mode graphics system that does its styling with CSS. So the only things left over from those times are ST-theme, which holds the representation of a loaded CSS style sheet, and ST-theme node, which I'll describe in the next slide. The magic behind ST is that it supports theming using CSS, just more or less just like GTK. The gnome-shell toolkit also does theming with CSS. Every widget that gnome-shell displays, the top bar, the buttons, the activities button, the drop-down menus, each one of those widgets has an object associated to it, which is of type ST-theme node. And an ST-theme node is just, it works like a node if you actually had a DOM, like in a web page, except that gnome-shell, of course, is not a web browser, so it doesn't have a DOM. It just has a different tree of widgets. ST-theme implements the CSS matching algorithm to see which nodes which get selectors applied to them. And later, CSS cascading, which is about copying the parent's properties from parent to child. That happens in a very ad hoc fashion in ST-theme nodes. I started porting this to Rust in November of the last year, and it's coming along pretty well. I have been paying my daughter to do the illustrations for this talk, so all the pretty drawings that you see here are her doing. The gnome-shell screen looks like this. We have the root window. How does one forward here? Oh, yeah. We have the root window, which corresponds to the root node, to the root ST-theme node. And then for each of the sub-widgets in there, like, the top bar has this st-theme node, and then each of the activities button, the clock, all the little drop downs on the right, each of those has its own corresponding st-theme node there. And the magic behind st and st-theme node is that it is able to do the CSS cascading on this tree to give the widgets here their final style. I'm sorry, we have a few duplicate slides. An st-theme node is the object that corresponds to each styled element and it has a bunch of properties. It has the font for that widget, the foreground, the text foreground, the text background, if the background of the widget has a gradient or an image, and all the CSS bubble for the outline, the border radius. These are kind of similar to those in the web world, but not entirely. And one thing I want to do here with this project is to actually make gnome-shell's styling be closer in spirit to the web, because that might make life easier for making themes. Now, we're going to be looking at a bit of code. I'm going to try to highlight the things I'm talking about. One thing I found with Big Blue Button is that between each slide transition, it paints the whole screen in white, and that really breaks the flow for describing code. So I'm going to highlight it with the highlighter here. I'm sorry that we don't have pretty syntax highlighting, but I tried installing the LibreOffice extension for code highlighting, and it just kept throwing Python exceptions. So, quality software and everything. Anyway, let's get started. Every function in ST that parses CSS properties looks more or less like this. This is the function to parse the foreground color property for an st-theme node. It takes in the node. This is the return value, the output color. It's a clutter color. And every single function in a st-theme node looks like this. If the thing has not been computed, then turn on the flag saying that it's computed. Load the properties for that object to make sure the parent had done the CSS cascade on there. And then for each property, look at the list of properties in reverse order, because in CSS, the last property, if you have duplicated names of properties, the last one wins. So we look at them in reverse. Fetch the property with index I. If the property name is color, then parse the color from the rest of the properties value and put it in this field, the foreground color field. If the parser says that value was found, we're okay, we return. And otherwise, if the parser says that the property is like inherit, really hard to write with a mouse. If the property's value is inherit, else break out of the loop. And let's look at what happens if we do that. We break out of the loop. If the node has a parent, then get the foreground color from the parent and copy it into our own foreground color. This is the CSS cascading. Otherwise, if the property couldn't be parsed or if it couldn't be found, just default to black. Otherwise, return. So this works fine. It's really ugly code. It's very repetitive. It's error prone, but it's it really screams, please refactor me. It's very repetitive, as I told you. So to summarize, every property parser in there ensures that the properties are read. If it was not computed, parse it. If inheritance is allowed for the property we're parsing, because not all CSS properties allow automatic inheritance. If inheritance is allowed, then ask the parent, otherwise use the default value. All the code is written by hand and it looks like that. We can certainly make that shorter. One nice thing, one nice difference between gnome-shell and librsvg is that gnome-shell actually has tests for the theme parsing. So I was able to use those very effectively for the new Rust-based parsers. If this were not a PDF presentation, the Nyan cat here would be animated, so you can imagine it. I'm sorry for the lack of animation. So let's see how the parsing code, what the parsing code looks like. When I told you about parse color, that was a lie. The function actually looks like this. It's called getColorFromTerm. And a term is libcroco's terminology for one of the terminal nodes in its syntax tree. It's a token, you know, it's a token that must be parsed. So we get a linked list of tokens here. We need to parse it. And we need to return a value of this type, which it's an enumeration that has value found, not found, or inherit. Give me 1 second here, please. And what this means is that if the parsing was OK, then we'll return value found. If there was a parsing error or the property was not there, we'll return value not found. Remember that CSS, the CSS specification says that if there's a parsing error, you should just ignore the property. Just don't exit the program or bring up an error or anything. Just ignore the property. And if value is inherit, we'll copy the property from the parent node. So let's start porting this to Rust. This is Rust code right here. The repr-c line means that this enumeration should have the same representation in memory as the equivalent C enum. If you're already a Rust programmer, please forgive the basic level of this description. This talk is really for the gnome-shell hackers, which may not all have had the chance to look at Rust code yet. So anyway, this is for their benefit. Then I gave the enum the same name as the C version. We have the same variant names for the enum. And then I started writing a little library in Rust called stylish. Stylish is, you know, for gnome-shell's styling machinery. So it's stylish with the SH because it's the gnome-shell. I'm really good at thinking of names, as you can see. Anyway, so this function stylish getColorFromTerm will replace the getColorFromTerm in C. It takes in a pointer to a linked list of crterm, and it will return an output value of type cluttercolor. We also return a getFromTerm result here. The point is to make this kind of API compatible with the existing code so that I don't have to refactor the whole C code before inserting Rust functions in there. This will get prettier later. So let's look closer at the actual implementation of the parsing function. Before we do that, let's talk a bit about CSS values. When you write a little chunk of CSS, you can have something like, how does one type in here? Text. You can have like color blue inherit. So if you write color blue, this is called a specified value because the user actually specified something here. If you write color::inherit, it's an inherited value. So Rust makes it very convenient to differentiate between those two cases. We'll define a tagged enumeration, generic on the type T. If you know a bit of C++, this is kind of sort of like C++ templates. So the values for this enumeration can be either inherit or a specified value of type T. In this case, the specified value will be of type clutter color. So what does this look like? The parser's internals are really going to want to return a Rust result. Result is a built-in type in Rust. And then we're going to have to translate that to a get from term result, which was the enumeration that told us if the value was found, not found, or inherit. So we invoke the parser. The actual parsing details are not important here right now. I just want to show you the conversions between the result types. So we're going to return, or the parsing function is going to return a specified value for a color, which we're going to convert to a clutter color. And for the error case, it's going to return a parse error. So we match on the result to see how to translate it. If it's OK with an inherit, then we return get from term result inherit. If it's OK with a specified value, then we convert the color value to its glib representation. The convention in GTK-RS is that the two glib functions convert a Rust value to a C value that glib can read, in this case, a clutter color. And we will return get from term result found. And if we get a parsing error, we ignore the error, and we just return get from term result not found. Ferris here, the Rust mascot, is a bit unhappy about this. She's happy that we are ignoring errors, and this code is actually pretty ugly. It's conversion code between types, But that doesn't matter for two reasons. First, right now, gnome-shell does not have enough machinery to give good errors to the user. So I'm not entirely sure yet how designers write the CSS for gnome-shell, but I imagine that it can be pretty painful if they accidentally mistype a property name or a property value, and then gnome-shell presents no errors, maybe put something in syslog with a jig warning. So that sounds painful. So eventually I want to have some sort of development toggle flag in gnome-shell that says, oh, hey, yeah, please give me a listing of all the errors I made in my CSS or something like that. But anyway, we're going to ignore them for now. And we are going to remove all this ugly code with the power of refactoring. And the refactor version looks nice and short and pretty like this. We're going to get a value from CR terms. The Rust representation is color. The C representation is clutter color. For parsing reasons that are not important here, sometimes we want a linked list of the terms, and sometimes we want to parse a single term, so we specify it here. And then we convert the return value of that to its gnome-shell representation, and we put it in the out parameter. And this whole chain of calls gives out a get from term result. And it refactors very nicely. And since within this we already have the machinery to do the type conversions and everything, we can very easily start plugging in new types. We had the color to clutter color. We have a custom type from gnome-shell, which is stgradient type. Needs no conversion to stgradient type, so this is a no-op. And that's all the code that I needed to write in order to add the stgradient type to the API that is visible from the C code. And I'll show you the definition for this value later. It's very nice. So back when we started doing the port of librsvg from C to Rust, I was writing C header files by hand, basically because I was still learning the Rust infrastructure, And since I was porting one function at the time, it was not a big deal to write a C prototype for it. So I just did that by hand. But now there's some discourse in the Rust community that one should actually use a tool to automatically generate header files back and forth. And they have very good reasons for that. So I got convinced. There's a tool called cbindgen. It's awesome. And it lets you configure it and say things like, OK, I'm going to write a C header file, not a C++ header file. My tool is going to be called stylish_h. You know, if hash not defined stylish.h, include the whole thing. It lets you include a warning so that people will not try to edit the auto-generated file by hand. It lets you have a list of type names to exclude, because these types are built into gnome-shell or libcroco or st, so I don't want the C header file generated from Rust to have duplicates. And then it lets you rename enum variants like this. What does qualified screaming snake case mean? Let's look at that. You tell it to qualify snake case. If this is the Rust code for an enum, and this is the C code that corresponds to it, the Rust enum is called st_foo, so the C enum is called st_foo, and the variant bar, we want it to be called st_foo bar to conform with GTK's and gnome-shell's naming conventions. Identifiers in Pascal case look like this. Camel case looks because of the hump here. Kebab case is keyword through the middle. That only works in Lisp though, not in C. Snake case, we also know snake case. Screaming snake case is the same, but in all capitals. And it's qualified because it has this prefix on every single variant. So qualified screaming snake case means to put the enum name before each variant name and make them capitals. So now you know the reason for that name. Oh, yeah. Let's talk a bit about CSS as it's used in gnome-shell and G. We use CSS lengths to specify many things. The length or the size of various items in the user interface. Sometimes they are given in pixels, and converting these to actual device pixels is not a problem. We just multiply this by the device's scaling factor if we have a high DPI screen. If we have length value in points, this means 12 points. It's not a problem, but we need to know the resolution of the display so that we can multiply the DPI by 12. And if it's given in terms of the font size, if a length is 1.5 ems, we need to multiply 1.5 by the current font size. So we need the DPI and the font size and the scaling factor to come from somewhere to convert them to device pixels. So gnome-shell would, the C code for gnome-shell would just pull those out of, various things in the gnome-shell environment, like, what's the parent node, or what's the theme, or what's the current display. But to communicate that to the Rust code, I made this little struct called normalization parameters, normalize params. And it contains the font size, the resolution, the scale factor, everything that is going to be needed to normalize lengths to the device pixels. So how do we do that? Rust traits are like sort of like Java interfaces. So we have a trait called normalize with a method called normalize. It takes the object itself and some normalization parameters and outputs something that depends on the type that knows how to normalize itself. For example, and there's also some length values or some CSS properties in gnome-shell that instead of just converting to real number, they need to be converted to integers because they want to be adjusted to the pixel grid. You don't want to have like 2.3 pixels on each side in the margins of a widget. You want 2 pixels or 3, but not something in the middle. So the Rust code has 2 traits, one to normalize to a real number and one to normalize to integers, to the pixel grid. But what was I telling you? What was I talking about? Oh, CSS lengths, that's right. So let's talk about CSS lengths. Lengths can have their numeric value and a unit, and the unit can be pixels, ems, x values, inches, centimeters, millimeters, points, picas, right? So how do we normalize a length to its device pixels? Well, we look at the unit in the length. Where's the unit? The unit is here. If it's pixels, then we just multiply the numeric value by the display's scaling factor. If it's inches, we multiply it by the resolution. If it's ems, so we just multiply it by the font size, etc. So every length value now knows how to normalize itself to an F64, which is the same as a double from C, right? And for the CSS value corresponding to be normalized, adjusted to the pixel grid, for example, there's this new struct called st_sides. Sides is used to represent both the margins and the, margins, border and padding from each widget. And you'll note that in the Rust types, this has lengths. It has floating point values. This is an F64 plus the units. But these are ints, and I32 is an int. So we don't implement normalize for sides. Rather, we implement normalize to pixel grid for sides. And I'm not going to show you the code. This has some just the rounding aside, apart from the normalization from the lengths. The important thing here is that from just looking at the code, it's very easy to figure out how each value type wants to be normalized to the pixel, to pixels. Does it want to be normalized to non-integer pixels or to the pixel grid? So that makes the code readable, I think. So I have been porting the parsers for the different functions in ST to Rust. Fortunately, most of them can be recycled from the code that is already there in librsvg. librsvg already knows how to parse CSS lengths, colors, font sizes, things like that. And gnome-shell fortunately keeps more or less the same CSS syntax. Once all of this code is done, I'll be able to make the gnome-shell code actually do the parsing for the whole style sheet in Rust, because it's done partly in C and partly in Rust right now. And once that is done, gnome-shell is going to need to tell Rust about its representation for the widget tree. If you can imagine this as the widget tree, and we have a node here, then we need an interface that can tell it's what's the parent element. If you have this node, this is the parent element. What's the sibling? If you have this node, then this is the sibling, the previous sibling, or the next sibling. If this is the node, does it have a class, an element class, or does it have an element ID? Does it match a pseudo element for, is it hover, or one of the pseudo elements in CSS? So the Rust crate that I want to use to do CSS matching demands that you implement this kind of interface for your own representation of the DOM tree. It's not terribly hard to do. It took us a while to do in librsvg because there was so much code that needed to be refactored. But for gnome-shell, I expect that it's going to be a lot easier. Switch to the next slide. Oh, yeah. These are some macros that we already had in librsvg that are completely reusable for the gnome-shell code. So, for example, there's a couple of custom property types in ST. There's an icon style property and a text align property, which are just can just have values which are identifiers. For example, if the user says requested, then we'll return an enumeration value with the same name, regular, symbolic. So this kind of macro makes it very, very easy to define the whole machinery for new properties. Like the property is going to be called stIconStyle. The default value for that property is requested from here. The possible values are just identifiers called this, and they map to these enumeration values. You can say whether the CSS property inherits automatically or not. This one doesn't. This one does. This means that for this one, if it is not specified, then the value for the property will be copied from the parent node. And this one doesn't inherit automatically, which means that if it's not specified, it will go back to the initial or default value. So with just a few lines of code, the whole machinery now supports these two properties instead of having, 50 lines of C code for each one to implement all the parsing and validation and cascading and everything. So this is nice. This is actually quite nice. One thing that I really am appreciating from porting the gnome-shell code to Rust is that it is also forcing me to fix some things in librsvg that had been long-standing bugs there. In CSS2, the font weight property could be font weight bold or bolder, or light or lighter, or multiples of 100. So like font weight 100, font weight 400. But Pango always supported arbitrary numbers in there, not just multiples of 100. So, for CSS4, I don't know if the CSS working group actually started supporting arbitrary values or if they gave up. But anyway, we now support any integer number between 0 and 1,000, which is the possible values for that property. gnome-shell has always used the font shorthand. The font shorthand is what lets you write font colon, font style, weight, size, font family. That's what the shorthand syntax looks like. And this gets translated into individual longhand properties. This font shorthand means that the font style will be italic, the font weight will be bold, the font size will be 12 pixels, and the font family will be Cantarell. And librsvg never supported that. I think it didn't because because property shorthands cannot be used in attributes. So if you have like rectangle in SVG and then you write a font attribute, that doesn't work because it's a shorthand. You need to write all these individually. But if you write a style attribute with inline CSS or something, that actually works with the font shorthand. Anyway, it's fixed in both librsvg, and gnome-shell is using that code now in my branch. So I'm really liking this thing about standardizing the property syntax for both projects now. What I described so far is what is done, what is implemented in the code right now. If screen sharing worked, which it doesn't in my machine because I'm using Wayland and GNOME 3.36 and OpenSUSE, screen sharing doesn't work. But But anyway, you wouldn't be able to see any changes from the normal GNOME shell, and that's because the parsers produce exactly the same values as before. That's guaranteed by the tests. So my GNOME shell looks no different from your GNOME shell, but mine is running some Rust code now. But let's talk about stuff that doesn't exist yet, the bright future, right? ST-theme node is an important place to reduce memory consumption in GNOME shell because every single widget in the screen has one of these. Every single widget in the screen has an ST-theme node, so it needs to be as small as possible. They are cached right now with a scheme that I'm not sure will work if we add complex CSS selectors. But anyway, librsvg is starting some machinery to cache the styling, so we can probably share that code in the end. I am fairly confident that we will have faster CSS matching in the end, in theory as fast as the one in Firefox, because the Rust crates that librsvg uses for CSS matching are the same ones that are used in Mozilla Servo, which is the new experimental infrastructure for Firefox, and that's merged into the mainline Firefox these days, and it's really, really fast. They do all the exotic things that are done these days for CSS matching. They use Bloom filters and things like that. So we'll have a pretty good CSS matching engine. That thing also supports complex selectors out of the box, sibling combinators, child combinators, all the exotic CSS combinators that browsers support. They are supported there. You just need to implement the big interface I showed you over here a couple of slides ago. And one thing I really want to have is a shared Rust crate between librsvg and GNOME shell, because they want to process pretty much the same CSS properties, and they have the same matching code and the same cascading, so we might as well share some code. It's kind of funny that my original plan was to replace libcroco, and that's exactly what I ended up doing. If I'm writing a shared Rust crate, well, it's probably not going to be called libcroco, but it's the equivalent, you know. Maybe other projects can use it. I thought that GNOME shell was the last code in GNOME that used libcroco, but it turns out that it isn't. Inkscape also uses it. It also embeds its own copy of libcroco in there. And I don't want to promise that I will look at Inkscape eventually, but you know, if it's also doing SVG and CSS and the code is kind of the same, we might as well do that and share some code. For the designers, I want to have really nice things for the designers. GNOME shell does not support @media rules yet. I don't know what would be useful there. Maybe the CSS media rule syntax for color schemes, for the dark themes maybe, or for the device resolution. If you have 200 dpi or higher, then use more detailed icons instead of, I don't know, deciding stylesheets at runtime or having other machinery. Do we want to support light levels in the environment? If it's dim, then change to night mode or something. So these things are possible through media rules. We need to add support for them in the parsing code. That's really easy to do. And GNOME shell just needs to decide which of these properties it wants to support and whether they would be useful for designers to have, fewer style sheets or simpler CSS or something like that. And as I told you already, I really want to have good machinery for reporting. Librs has been moving towards having better error reporting internally, and I want to expose it to the outside API somehow. Give me a listing of all the parsing errors, or which properties got cascaded where, to make a CSS Explorer like in web browsers. I don't know, but to have better error reporting to make designers' lives easier. all of this is vaporware. It doesn't exist yet, but we'll get there. We'll get there. Rust fortunately makes this fairly nice to do. This is Ferris doing the CSS cascade, so feel free to partake. And that's all I have. I want to thank a few people for making this possible. My daughter Luciana for all the illustrations, my dog for serving for Robert Duck debugging. I explain things to him and he barks if he detects a bug, and he doesn't bark if he doesn't, so he gets it wrong. My wife Horacio, who supports because I sit on my butt here all day writing code, and she supports with schoolwork and such. The Mozilla Servo people have been awesome in supporting with the CSS machinery and the CSS processing crates. The gnome-shell people are lovely. They build basically the most important user visible thing in GNOME, which is, town square. Everybody goes to the shell to do their thing, and they go into the little applications like individual buildings and such. And finally, the technique of narrating code comes from Katrina Owen's videos on YouTube. They are great. You should look at them. And that's all I have. I'll be happy to answer questions.
Thank you, Federico. You can find the questions in the Etherpad, and in the shared notes, you can click on the Etherpad link and find your presentation, talk 5.
Thank you. Yeah, so the first question is, you said replace libcroco with a nice maintained Rust module. How does that work? Do Rust maintainers just appear by magic? Let me show you a trick. No Rust maintainer, poof, a Rust maintainer appears. So yeah, I intend to maintain this for a while, because if we have a shared crate between librsvg and gnome-shell, I intend to maintain that while. The boss fight is fortunately not one. Paolo Borelli already knows that code fairly well. So we have 2 people who know how to work in it, at least. So yeah, that's my promise for a few years, to keep maintaining that. Also, the CSS matching crates that we have from Servo, those are maintained by Mozilla people, and I think it's safe to say that Mozilla will be sticking around for a while. So, hopefully we won't have problems there. Second question in the Etherpad: do you feel less productive, as in speed of implementing features, fixing bugs, writing code in Rust versus other languages? Not at all. Not at all. The thing that I experienced when learning Rust is that, yes, it took me longer to write during my learning period, and that seems to match other people's experience in the Rust world. But once you get it, every Rust developer seems to pass this phase, which is called fighting the borrow checker. But once you figure it out, and once you figure out the data flow in your program, you stop fighting the borrow checker, you understand what the compiler is telling you, and it flows very smoothly. Once you get to that point, it took me maybe a year, but it's not bad. It's not bad. Don't be scared. I actually am very productive in Rust because I'm able to use a very strong type system, a very nice macro system. So the macros I showed you for the for the properties here, these macros just makes life so much easier, and they let you write or not write so much code really fast. So it's really nice. I find myself very productive in Rust these days. So I hope that's reassuring. Next question: are there projects that are next on your list for corrosion, which or rewriting in Rust? This is total vaporware except for some working code and some tests that pass. I am trying to refactor libjpeg turbo into safe Rust code. The idea is to use the simd functions in libjpeg turbo from safe Rust code to do a new JPEG codec. Send me an email if you would like to work on that. If you are experienced with image codecs, send me an email. Next question, is there step-by-step rough and simple instruction for putting GNOME shells to Rust? Not yet, but that's an excellent question. I should do that and write something up in a blog post. So yeah, maybe I should write one next week or so. Thank you. A note about, next question about @media rules. Would be cool to explore for desktop pad font resolutions. Maybe, I don't know. I'm the kind of person that knows how to implement a CSS processing infrastructure, not how to actually use CSS in the web or something like that. It's designers who will have the last say on this, what they will find useful and what not. But yeah, you know, if there's useful properties that you would like to have in GNOME shell, tell me about them or file bugs in the stylish project, and I will definitely look into implementing them. Next question, do you replace CSS parsing in librsvg and GNOME shell? Is GTK next? I don't know. GTK 3 and 4 have their own CSS parsing code. It's not libcroco. I think Benjamin Ott and others wrote a new CSS machinery for GTK, and it's actually fairly nice. I was looking at it to see how it did, and it's pretty good. So I don't know. It would definitely be useful to standardize on the supported syntax for properties. You know, do they all support the same kinds of colors? For example, GNOME shell uses for the color properties, GNOME shell uses it used to use the libcroco parser for colors, which just supported the RGB syntax, you know, RGB parentheses 3 values, or the hash hexadecimal digits, but it didn't support HSL and HSV, I think. But with the new code from librsvg and servo, that comes out of the box, so it's supported. I don't know if GTK supports that, but it would be nice to standardize on at least the property syntax. I don't have plans to replace CSS parsing in GTK with Rust, but I don't know. We'll see in the future. Next question, does Rust build on all interesting architectures where we need GNOME shell these days? Somebody answered there. Debian has been building Rust toolchain for all the architectures Debian supports, and that's enough for me because they support the weirdest architectures out there. They are still building for like Spark and MIPS and such. And now there's a proposal that came out last week to make ARM64 a tier 1 supported architecture in the Rust compiler. That means that it's like one of the good ones. Like it will work just as well in the Rust compiler as, you know, x86 64. So for people thinking of buying ARM64 hardware, yeah, that should work just fine. The next question is, a lot of this work would seem relevant to GTK. Pixel rounding media queries, will this work in SDK be reusable by GTK? It's the same question as above. Liballigator as the new name. I like it. Maybe liballigator instead of stylish, and yeah, I'm sure we'll be able to make all sorts of nice puns with liballigator. The big question, what is the dog so happy about? Let me show you my dog again. Oh, so that photo is from 2 weeks ago. It's the first time that my poor dog was able to go to a park with trees and everything during the quarantine. So he was just out of his mind happy. So that's why he's so happy. Anyway, I don't see any other questions on the Etherpad. If that's everything.
Yeah, it looks everything. Yeah. Thank you,
Federico.
Federico.
That's all I have for you. Thank you. Thanks for attending.
Thank you, Federico, for excellent, not so rusty talk. And we will be back in a minute with the next one. Thank you.
All right. Thank you.